Today we do physics, right? And measurement is more like the first topic for most textbooks in physics. Measurement is one of the most important topics in science. Please pay attention. Before I even go into measurements, I want you to understand that if you're going to do physics calculations effectively, there are certain topics in maths that you should have mastered. One of them is going to be that you should have mastered variation. For example, if I have a formula like density, which is equal to mass over volume, right? Mass over volume. You should be able to know that this means that density is inversely proportional to volume, and density is directly proportional to mass. You should know what that means. And when you say that it's inversely proportional to volume, they're saying anytime you increase density, what happens to volume? It will decrease. And anytime you decrease what now, density, what happens to volume? When you what now? Increase. When you say they're directly proportional, this symbol here now is called rho in Greek. It's a symbol used to represent density, right? So this one that is directly proportional, you need to know that what now? Increase in what? Density will mean what? Increase in mass. Increase in what now? Decrease in density will cause what now? Decrease in what? In mass. Is that okay? Apart from variation, there are other topics that you need to know to do calculations in physics effectively. Alright? Another topic that's important for physics is knowledge on what now? Subject formula. That's after all those basic stuff that we have learned for foundation for basic mathematics, right? What is it? I gave you a formula now, like this is equal to this over what now? This, right? Sometimes they'll ask you to find what? Volume, instead of looking for what? For mass. So I have to make volume what? The subject. How exactly volume is going to be this? You got what I'm saying? That's not ask you for mass. Mass is going to be what now? Density times what? Times volume. All of this is basically, you can go perfect and what now? Practice from maths. Then you come back here because we do a lot of applications of this word now with time. Is that alright? Okay, so measurement is what now? It's the method that is applied to find a quantity, right? For example, if I want to measure, I want to find out how long something is. What I'm measuring what now? Length. Do you understand? I have to measure, find what now? The length. Are you with me? If I want to find out how hot or how cold the thing is, that quantity is what now? It's temperature. You get what I'm saying? If I want to find out the interval between which things occur in what? In nature, I was talking about what? Time. You get what I'm saying? If I want to find out how heavy a thing is, I was talking about what now? Mass. You get what I'm saying? If I want to talk about what now? The rate at which something is what now? Is changing its speed. I'm talking about what now? Acceleration, like that. So many what now? Different what? Quantities. How we measure them. So, based on what we are discussing, there are different types, different classifications of measurement, right? Under measurement, rather. But I want to talk about what now? Fundamental and derived what? Quantities under measurement. Are you with me? There are different types of quantities, but the ones I want to talk about is what now? Fundamental quantities are what now? Derived what? Quantities. What are fundamental quantities? Fundamental quantities are independent from what now? Other quantities and are not defined by other quantities, nor obtained by what? Combination of other what? Quantities. For example, mass. The mass of a substance cannot be defined. They are independent of what? Other what? Quantities. You see, mass is what? Mass is the quantity of matter a body what now? Contain. You know what I'm saying? Yes. And then mass, I did not get mass by combining anything. In fact, one of the things that you come to see is that they also have fundamental what now? Units. The unit of mass is what? Is kilogram. Are you getting it? Temperature is another one. Unit of temperature is what? Degrees Celsius, Kelvin, Fahrenheit in that, right? Another one is what now? Is length. Unit of length is what? Is meter. All these guys, you cannot what now? They are independent of other quantities and cannot be defined or derived from what now? From other what? Quantities. Is that okay?
Yes.
So, fundamental units are the units of what now? Fundamental quantities. So, what exactly is the purpose of a unit? As a units are used to identify what now? Quantities. For example, if I just write 40, you cannot know exactly what this 40 here would now represent. It's just magnitude, it's just size. But if I write 40 centimeters. You know I'm talking about what now? Length. If I write 40 kilogram, you know I'm talking about what now? Mass. If I said 40 degrees Celsius, you know I'm talking about what now? Temperature. You understand what I'm saying? So units are used to identify what now? Quantities. Is that right? Okay, at this level, right? You have 7 fundamental quantities. You get what I'm saying?
Yes.
You have mass, you have what now? Length, you have what? Time, you have temperature, you have current, you have what? Amount of substance, and what now? Luminous what? Intensity. Are you with me? The units, these are fundamental units. Actually, fundamental unit for mass is supposed to be gram. I'll explain that to you when I'm doing unit conversion. But because gram is too small, it was generally agreed that it should be what now? Kilogram. It's a higher what now? A higher unit. So that of mass is what? Meter. Time is what? Second. And then what now? Kelvin for temperature. Actually, temperature has several. We also have degrees Celsius or degrees centigrade, right? But most of the calculations that you do, especially in chemistry, you'll be using your units for what now? For Kelvin. Kelvin actually the absolute value. I'll explain that with time, all right? Other units for temperature, it says what? Either degrees Celsius, degree what now? Centigrade. And we also have Fahrenheit scale. Is that right? When we do temperature fully, I'll explain all that. Then we have current. Current, the unit is what now? Ampere. Amount of substance, what? Mole. And then what now? Luminous intensity is what now? Candela. Is that okay? Okay, very quickly, I'll talk about derived quantities. Then I'm going to spend more time around here. Because this thing here, I'll explain it in terms of dimensioning. This is a gateway. So what are derived quantities? They are defined by other quantities and what now are obtained by simple combination of other quantities. Let me try and explain using area, for example, right? What is area? Area will always be length times what? Times length. Right? Okay, I'm spelling the British form of length. Let me redo this. Are you? No. Okay, now, area is what? And please take note of this, right? When we are saying length in physics, I will explain this so much more when we're doing maths, right? When we're saying length in physics, it covers any distance between what now? 2 points. When I'm talking about 1 dimension, 2 dimension, and 3 dimension for what now? For measuration, you understand that better. Any line at all, any distance that's from one point to another measures what now? Length. So when I'm talking about length in physics, whether I'm measuring from this down here upwards is what now? Length. But that length is called what? Height. If you're measuring from down up is height. When I'm measuring from up down is what now? It's length. That's depth. Do you understand? When I'm measuring what now? Let's say I'm measuring what? The thickness of this. It's also what now? Length from one point to another. You understand? Yes. As long as I'm measuring, if radius is length, perimeter is length, all of them is a standard. If the distance is what now? Is length. Take note for that. In physics now, under measurement, the word length refers to what now? Any linear what now? Distance at all. Is that okay? So definition for area is what now? Length times what? Length. For example, if you want to look for the area of what? Area of a rectangle, you say length times what? Times breadth. But in physics, the breadth is also what now? A length. So you understand what I'm trying to say? Are you getting it? If you're looking for the area of a circle, it's going to be what? Pi r squared. This r here is what now? Is what? It's a length. Again, it's a radius. You understand what I'm trying to say? So it's like this length times what now? Another length. This is a constant time, which is approximately what now? 22 over what? 7. Do you understand what I'm saying? All of these things will come clearer later, but just know very well that what now? As long as it's area, it will always be what now? That you're combining what? Two lengths. Is that okay? Yes. We do this again, right? Yes. Derived quantities, I say they are defined by other what now? Quantities. And are obtained by simple what now? Combination of what now? Other what quantities. So you remember the unit of length. You know the length what? Meter. And meter times meter is meter what now? Squared. You get what I'm trying to say? That's how they get their unit. Their unit is also what now? Derived. They are derived units are the units of what now? Derived what? Quantity. So just like the quantity are derived, the units are also what now? Derived. What is volume? Volume is what? It's length times length times length. So you see what now? Meter cube. You get what I'm saying? What is speed? Speed is length over what now? Over time, which is distance now in this case. The length here is what now? Distance over what? Over time. You get what I'm saying? Length over time. So you see meter per what now? Per second, meter per seconds. You get what I'm saying? Now what about acceleration? Acceleration, take note please. Speed and velocity sometimes are interchanged. They can be used interchangeably in physics, because although they mean the same thing, one specifies direction, the other one doesn't specify what now? Direction. All this I'll explain what now in due course. Is that right? So when you're talking about what now? Velocity, you specify direction. When you're talking about what now? Speed, you don't specify what direction, but both of them are measuring what now? How fast something is what now? Is moving. You understand what I'm trying to say? Distance covered by unit what? Time. Is that okay? Then acceleration is what now? Velocity per unit what? Time. So I'm going to have what? Velocity over what? Over time. Velocity which is not speed. Are you getting what I'm trying to say? So I'm going to have meters per second per seconds. Are you getting that? Do you understand what I'm trying to say? So all of them are defined by what now? By other what? Quantities. Density, force, pressure and all that. Is that okay? So these ones are what now? Derived what? Quantities. The first sets are what now? Fundamental what? Quantity. Those ones are independent of other quantities. This one are dependent on what now? Other quantities. Is that alright? So you see density is defined as what? Mass over what? Volume. Force is defined as what now? Mass times acceleration. You can see that in their units, right? Then you can see that what now? Pressure is defined as what? It's defined as what? Force over what? Area. So you see what now? Force over area. Force is Newton and what now? Meter squared. All those are what now? Their units. I'll explain this in a bit. In the next what now class, I'll explain all of this, right? Now let's use dimensioning to explain what we just talked about, as in the whole concept of derived what now quantities. Is that okay? Under dimensioning,